Welcome. So in this part, we're going to be talking about the factor theorem, Now, in order for x minus alpha to be a factor of the polynomial p of x, the remainder must be 0. It must be 0. We state this result as the factor theorem. So this is exactly what we're speaking about at the very start of this lesson. And as you can tell, the remainder theorem and the factor theorem are pretty much identical. The only little thing that makes the factor theorem different is that your end result is 0, and therefore the divisor is a factor. So it says if beta x minus alpha is a factor of p of x, then p of alpha over beta is equal to 0. Perfect. So what exactly is this telling us? Well, if my divisor here is beta x minus alpha, and that's equal to 0, and now I solve that, I'm going to get x is equal to that. And now if I sub that in to p of x, if I get 0 out, that means that my original divisor was a factor. So this is exactly what we saw previously with the remainder theorem, but when you have the remainder theorem, you don't get 0 out. You get a remainder. When you have the factor theorem, you get 0 out because it's going in there perfectly. You're not getting a remainder. So let's now answer these questions. It says, show that x minus 3 is a factor of p of x here. So remember, there are two steps here. There are two steps, step 1 and step 2. Step 1 is taking your linear expression here, so x minus 3, you set it equal to 0, and then you solve for x. Then you substitute that in to the polynomial that you've been given. So that's going to be 2, 3 cubed minus 11, 3 squared plus 16, 3 minus 3, which is going to be 2, 27 minus 11, 9 plus 48 minus 3, which is going to be 54 minus 99 plus 48 minus 3, which is going to be 54 minus 99 will be minus 45, plus 48 minus 3 will be 45, and that's going to be 0. And because we get 0 out, that tells me that x minus 3 is a factor because we got 0 out. So by getting 0 out, we're proving that we're not getting a remainder, and therefore this is a factor of p of x here. Let's now do the exact same thing over on this side now. Whoopsie, David. So remember, you've got two steps that you've got to follow here. Step 1 and then step 2. So the first thing you're going to do is you're going to take what you've been given here. So that's 2x minus 1. You're going to set it equal to 0 and then solve. So it's going to be a half. Then you're going to substitute that into the polynomial that you've been given. So I'm going to end up with, now this is going to be a mess. It's going to be 2 a half cubed plus a half squared plus a half minus 1. Now this is going to be 2 1 on 8 minus 1 on 4 plus a half minus 1, which is going to be 2 on 8, which is 1 on 4. Just simplify it straight away, which is going to be 1 on 4. And then 1/2 is the same thing as 2 on 4. And then 1 is the same thing as 4 on 4. So as you can see, I'm just getting all my denominators the same. A half and a half, sorry, a quarter and a quarter. Well, all of these have the same denominator. So 1 plus 1 is 2 plus 2 is 4. So it's going to be 4 on 4 minus 4 on 4, which is equal to 0. So the fact that we're getting a remainder of 0 out is telling me that 2x minus 1 is a factor of p of x here. So that's really what we're doing here. So the remainder theorem, factor theorem, very, very similar. But the factor theorem, when you are subbing in that value, you're getting 0 out. Okay, let's go through this one right here, which is, slowly building up to what we eventually want to do. So it says, show that x plus 1 is a factor of p of x here, and hence find the other linear factors. Okay, so the first thing that we have to do here, step 1, is we need to show x plus 1 is a factor. And we know how we're going to do that. The way we're going to do that is we're going to go p of negative 1, because we're taking this, we're setting it equal to 0, and then we're subbing it into this right here. So we're going to get negative 1 cubed minus 4, negative 1 squared plus negative 1 plus 6, which is going to be negative 1 minus 4 minus 1 plus 6, which is going to be negative 6 plus 6, which is going to be 0. So therefore, x plus 1 is a factor. Perfect. Now that we've done that, the next thing that we need to do, so step 2 here, is it says find the other linear factors. Find other linear factors. Now, how are we going to do that? If we have one factor, how are we going to find the other factors? Now, let's just leave this for a moment, and let's just come over here. You don't have to write this down, but I just want you to think for a moment. Let's say I gave you the following. Let's say a factor of 54 is 9. And then I said find the other factor of 54. How would you do that? So a factor of 54 is 9, and find the other factor of 54. Well, what you would do here is, and I think you'd do it almost instinctively, is you would take that 54, you would divide it by the factor that you were given, and you'd get 6 out, and this other 6 is my other factor. Because we know that 6 times 9 is 54. So, of course, there are other factors to 54, but we know that 6 9s are 54. So, as you can see, what you're doing is you're taking that factor that you've been given and you're dividing it by what you have here. So, it's 54 divided by 9, and you're getting that other one, and you can see how it works here. So, you're taking the factor that you've been given and you're dividing. So, that's exactly what we're going to do here now. So, what we're going to do now is we're going to say, well, we know that one of our factors is x plus 1. We're now going to divide it. We're going to divide it by p of x, or we're going to go p of x divided by this rather. So x cubed minus 4x squared plus x plus 6. So let's see how we go here. So I'm going to get x squared, then I'm going to get x cubed plus x squared. Then I'm going to subtract here. I'm going to get negative 5x squared. I'm going to bring down this. Then I'm going to get minus 5x here. Then I'm going to get 5x squared. Then I'm going to get negative 5x here. Then I'm going to subtract. And then I'm going to get 6x here. I'm going to carry down this 6. I'm going to get 6 here. And then I'm going to go 6x plus 6. I'm going to subtract here, and I'm going to get 0. Now, why is it very, very important that I got 0 out here? Well, this is my remainder. I had to get a remainder of 0 because I knew that x plus 1 was a factor. So I knew that it went perfectly into this. So this right here had to be 0. And what have we found here? What is this? Well, this right here is my other factor. So this is my other factor. So by doing this, I have found the other factor I was after. So by going x plus 1 divided by p of x, I found my other factor. Now, we know, based on what we've learned about polynomial long division, and I'll call this step 3, is we know another way we could write this now. We could say that p of x, and let me get another color here, we could say that p of x, so this right here, is going to be equal to the divisor, x plus 1, multiplied by our quotient, x squared minus 5x plus 6. And then the last thing that we can do here is we can factorize this even further. We could go x plus 1, and now I could factorize this quadratic. So I'm going to now factorize this quadratic, and what's that going to be? It's going to be x, I'm blanking. Is it going to x minus 3, x minus 2, right? Because minus 3 times minus 2 is plus 6, and then negative 3, then negative 3 minus 2 is negative 5. So that means I'm going to get this, and as you can see, I found all my factors. I found this one, I found this one, and I found this one. So I've done what I've needed to do. I found all the factors that I was after. So what I did is, just to go through it again, I first showed that the first factor I was given was a factor by showing that it equals 0. Then I used that to divide my original polynomial to find my other factor. And then the last thing that I did here is I factorized the quadratic, and I might even write that in. So what I did here is I factorized the quadratic. I factorized the quadratic. And that's how we approached it. So in those 3 steps there, we have found the other linear factors. So the linear factors are x plus 1, x minus 3, and x minus 2. And that's what we've done here, and you can see how we've slowly built up from everything that we learned previously to get where we are now. So hopefully all that's made sense. In the next part, we'll kind of flesh this out a bit more and see how all of this is kind of wrapping up and getting to what our final skill has to be able to be. Hopefully this made sense, and I'll see you in the next one.